All right, the fourth lecture in this series on algebra review is on rounding and estimating. And in this lecture, we are going to round numbers. And then we're going to use these numbers to estimate sums, which are two things added together, differences, which are things that are subtracted, products, which are things that are multiplied together, and quotients. Okay, so let's imagine this on the number line so we can kind of see what we're doing. Because if somebody asked you, hey, how far do you drive every day to work? You're not going to answer them, well, I drive 12.1265 miles. You're going to give them an estimate. You're going to say, well, I drive about 15 miles or I drive about 10 miles. You're going to round that number to some specific place. And rounding is something that we do all the time in the back of our head and not even think about it. But formally, let's just say we have a number here. Let's say this is the number 4,732. Okay. So if I said, here's the nearest 10, right? 4730 and 47340. I know that's hard to read. But if I said, well, which 10 is this closest to? You would round it to the nearest 10. You could tell by looking that it's closer to 4,730. And then we can go out a little bit further and say maybe this is 4,700 and this is 4,800. And which hundreds place is this closer to? Is it closer to 4,700 or is it closer to 4,800? You would say, oh, it's definitely closer to 4,700. So this number rounded to the nearest 100 is 4,700. And then we can go further out. Here's 4,000. And maybe here's 5,000. And which 1,000 is it closer to? Well, it's apparently closer to this 1,000. So it would be 4,000. 5,000 would be this number rounded to the nearest 1,000. But formally, let's see what we're doing. And this includes decimals. So I'm going to assume that you know a little bit about place values and decimals. So let's round to the nearest 100. Let's formally do this. 4,732. Okay, we already know the answer is 4,700, but let's look at the procedure for rounding. So the first thing we're going to do is we're going to find the place value we're rounding to. So in this case, we're rounding to this number right here, 7. And the next step is we're going to look at the digit to the right. So in this case, the 3. And then we're going to make a choice here. If that number is less than 5, we're going to do what's called round down. That means replace numbers to the right of the place value with zeros. So this number 3 is less than 5, so we're rounding to the hundreds place. When we round down, this is going to become 4,700. We just simply round down like that. If the number is greater than 5 or equal to 5, we do the same thing. We replace the numbers to the right of the decimal of that place value with zeros, but first we increase the place value by 1. For example, we'll use the same number, except we'll do 4,782. We're going to round to the nearest 100. So you can see we start here. We look at the decimal place to the right, or the place value to the right, and we got an 8. 8 is 5 or more, so we round up. So these become zeros, but we increase this place value. So 47 becomes 4,800. What about decimals? Let's do a decimal before we get on. Let's round 47 and 835 thousandths to the nearest hundredth. Okay. Now, in this case, you don't necessarily have to replace these with zeros, because a zeros at the far right after a decimal place don't mean anything. So it's going to be very similar. And it's okay to keep the zeros. That's perfectly acceptable, especially when we're talking later in science when you get to significant figures, which is a little bit out of the scope right now. But I'm not going to really harp on the extra zeros added out here, unless they're before the decimal point. Then they do matter. But after the decimal point, the zeros aren't that important. This is the tenths, and this is the hundredths. So we're looking at this place to round 2, and we look to the place to the right, and we have a 5, and 5 is greater than, so this 3 becomes a 4, and we can leave it like that, 47.84. However, this is also acceptable. However, most of the time you would just see 47.84. Okay, so rounding, estimating, sometimes you're asked to estimate to a specific place, but sometimes you are not. So generally when you estimate sums and differences, you round each add-end, minuend, or subtrahend. Let me explain what these are. Add-ins are things that are added together. Minuend and subtrahend are what you subtract when you do a difference. You round each of these to the highest place value. For example, let's say we're doing 407 plus 395 plus 85, and we want to estimate this. Just estimate. All it says is estimate. It doesn't say estimate to the nearest 100. If that was the case, then you would round each of these to the nearest 100. But if the problem just says estimate, here's how we would take this out. We would round each of these to the nearest 100 because 100 is the highest place value. Because it wouldn't make sense to just to get the accuracy on 85. You won't want because the tens place wouldn't really help you that much. So we'll just say this is the idea is to make it easy, not hard, easier to add. If we estimate all of those, 407 is closer to 400, 395 is closer to 400, and 85 is closer to 100. So now we can do this and estimate that to 900. Is it going to be this number, the actual sum rounded to this number? No, that's not always the case. Especially when the numbers are close to the middle of the place value. That's not always going to be the case. But 900 is a reasonable estimate for adding these three numbers up. Let's add those numbers up real quick and see what we get. 407, 395, and 85. That's 887. So that's pretty good estimate. The same thing goes with subtract and decimals. Just estimate 92.147 minus 10.175. If I was to estimate those, I would do 90 minus 80 and get, or 90 minus 10, I'm sorry, and get 80. Because those are closer. 92 is closer to 90. 10.175 is closer to 10. You subtract those and you get 80. So you pretty much, the decimals and all that kind of stuff don't really matter in an estimation. Now, when you're doing multiply and divide, You usually, let's just say we're going to estimate. It just depends. If we were going to estimate this product, okay, we wouldn't estimate this to the nearest 100. We would do each of these to the highest place value. Round these to the highest place value. So this would be 300 times 60, which is easy to multiply if you remember multiplying by factors of 10 or multiples of 10. This is 18. 3 times 6 is 18, and then we add 1, 2, 3 zeros. Now the exception to the rule of this is single digits. Let's say we're going to estimate 347 divided by 5. Okay, you wouldn't round this to the nearest 10. You would divide 350, or you could do 350 divided by 5 and get 70. Or less accurate would be 300 divided by 5 and get 6. Either way, you're not 60, I'm sorry. Either way, you're not too far off those estimations. So it's really just dependent on how easily divisible this is, because it just happens that when you round this to the nearest 10, it's a multiple of 5. If it was 342, now that would be different because 34 is not a multiple of 5. So you kind of want to round to a nearest multiple in that case as well, just so you could get a good round estimation. You shouldn't have decimals and all this kind of stuff when you estimate quotients. All right, let's look at another one. How about 38.6 times 4.1? Okay, so in this case, I would do 40, because this rounds to the nearest 10 is 40 times 4 and get 160. Okay. One last thing here I want to talk about before I close this up, because I don't think I'm going to do any word problems here, and that's cluster estimating. I just want to review the basic facts of estimating so that when we start doing it and the algebra, that you already have a basic familiarization of what I'm talking about. Okay, let's say we're going to add 97 plus 103 plus 98 plus 99 plus 104 plus 96. Okay. Now, if you look at all these numbers, they're all pretty close to 100. All of them round to 100. So instead of, you could add 100, 100, 100, 100, 100, 100, or you could just do this. They all round to 100, and there's 6 of them. So if you see them all clustered together like this, and there's a bunch of sums where they're relatively close together, you can estimate this way as well. And that is going to end the lecture on rounding and estimating. The next lecture is going to be over adding and subtracting decimals. So we're going to make sure we have a good review on how to add and subtract decimals, and we'll see you then. Thanks for watching.